We now know about reference frames, where they are defined and how they are generated. The robot state publisher generates the different reference frame. But the actual functionality of TF, which is keeping track of the spatial and temporal relationships between reference frames, is implemented in the TF2_ROS package. In other words, all the linear algebra computations necessary to find out the actual translational and rotational offsets between different objects is done with this package. For example, given a pose of an object in a certain reference frame, we can transform it into a target reference frame. And this is exactly what we will be doing in this module to actually compute the target pose for our robot arm end effector to manipulate the object detected by the logical camera. But we can also do some advanced functionalities like time travel to query information or the spatiotemporal information about the past as well, but we will not study those aspects in depth in this course. Anyway, I started this video with the TF2_ROS package, but you might probably be curious if there was a TF1_ROS package as well. Yes, it was not exactly called TF1, but it was just called TF, and it still exists. Some applications continue to use the TF_ROS package, and we will soon learn a few command line tools from the TF_ROS package. In the ROS package TF, all TF functionality was implemented in one ROS package, but with TF2, the division of functionality is much more clearly structured. And use of TF2_ROS package is, however, currently recommended, and most of the TF functionality has been migrated as well to TF2_ROS and the other packages in the new structure under TF2_ROS. But the main advantage with TF2_ROS is the availability of a transform buffer, which can cache transform information for a specified duration. We will explore the transform buffer in further detail in the next two videos. So, we have been talking about spatiotemporal relationships for a while now. But how are they actually quantified? They are quantified via the geometry_messages transform stamped ROS message, which is a message type to represent 3D transformation. That is, it comprises of a field for 3D translation, 3D rotation in quaternion so that rotations can be uniquely represented with respect to a given reference frame. Rotations in RPY are also supported for simplicity, but it is strongly recommended to use quaternions for computations involving rotations. And the TF topic is used to aggregate all transforms from our environment so that transform information can be made available to all ROS nodes in our application. The TF topic carries the TF2_messages TF message data type, which is just an array of transform stamped message types. Note that it was because of this topic TF that we were able to check the TF checkbox in RViz when